All right, I'll get back to 7.2 here. So we're talking about trigonometric integrals. And we looked at some involving sines and cosines. And now we're going to turn our attention to ones that involve tangents and secants. Now remember that the derivative of tangent x is secant squared x. And the derivative of secant x is secant x tangent x. Okay? So in this example, where I want to integrate tangent cubed x secant to the fourth x, I guess I'm looking for a u substitution here. And secant to the fourth x is the same as secant squared x times secant squared x. And secant squared x is the same as 1 plus tangent squared x, right, using my Pythagorean identity here. So where I see the secant squared x term, I replace that with 1 plus tangent squared x. And now that allows me to use the u substitution, right? The derivative of tangent x is secant squared x. So if u is tangent x, then I'll be able to knock out the rest of that integrand right here at the end. And the new integral then would be the integral for u cubed times 1 plus u squared du. When I distribute the u cubed into these two terms here, I'm integrating u cubed plus u to the fifth. And so that's me 1/4 u to the fourth plus 1/6 u to the sixth plus c. Again, don't forget the plus c. That's an indefinite integral. And replace u with tangent x now. So my answer will be 1/4 times tangent to the fourth of x plus 1/6 times tangent to the sixth of x plus c. Okay? That's not the only way I could have done that integral, by the way. I'll mention another option that we could take here after we look at the guidelines. But just another example would be, okay, what if I increase the power of the secant x term to a power of 5 instead of a power of 4? So I'm integrating tangent cubed x times secant to the fifth of x. Well, okay, now I wouldn't want to handle this the same way, right? Because if I break away a secant squared x term, then that's going to leave me with tangent cubed x times secant cubed x times secant squared x. A secant squared x, that's the same as 1 plus tangent squared x. And I guess I was, because that's an odd power now, I'm still going to have an extra secant x term, okay? So I'd have a secant cubed x. And so a u substitution would not work there if I were to try to let u be tangent x. In this problem, though, if I break away one tangent x term and one secant x term, which I've got there, then I know that or using the Pythagorean identity, this tangent squared x term that I see, that's same as secant squared x plus 1 is tangent squared x, okay? So I use that identity there, and I'm getting everything involving secants in the integral, except for this last part here, secant x tangent x, and that allowed me to use a u substitution. If I let u be secant x, then du is secant x tangent x dx, right? So I'll be able to knock out the rest of that integrand there. And the new integral involving u would be the integral for u squared minus 1 times u to the fourth du. Okay? And then when I distribute the u to the fourth into those two terms there, I am integrating u to the sixth minus u to the fourth. So I keep the base and add the exponents, right? So I get u to the sixth du. And then, well, the antiderivative of that would be 1/7 u to the 7th minus 1/5 u to the 5th plus a constant. And the last thing there would be to replace u. So u is secant x. So my answer would be 1/7 times secant of the 7th of x minus 1/5 times secant of the 5th of x plus a constant. Okay, so here's some guidelines for evaluating integrals involving secants and tangents. You got to be in this form. So you got you're integrating tangent of x to the m power and secant x to the n power. Now, if n is even, if the power of secant x is even, you're going to save one secant squared x term and convert the remaining factors to tangents. Then let u be tangent x. So just like what we did with this problem, right? We got n is even, so I had a power of 4. I'm saving a secant squared x term, and I convert the rest of this to tangents using the Pythagorean identity there, okay? So secant squared x minus tangent squared x equals 1. So, and I again, probably from what you notice here, in this section, like the Pythagorean identities are used quite a bit, okay? So you definitely got to make sure you know those. And then item 2 here, if m is an odd number, okay, like we saw in this problem, it says that you're going to save one secant x times tangent x term and convert the remaining factors to secants. Okay, and then let u be secant x. Well, that's exactly what we did right here. Okay, now there's a note saying in this last example, or excuse me, in the first example, I could have tried to get u to be secant x. So if n is even and m is odd, okay, n is even and m is odd. So what I did here again is I broke away a secant squared x term and I let u be tangent x. Well, I didn't need to do it like that. I could have broken away a secant x times tangent x term and then let u be secant x. Yeah, that's what the note says there. That would have worked fine also. So the point of me saying that is because, you know, I might have an answer that involves secants. That's not a wrong answer. Okay, it's just a different answer. Okay, but both are okay. It's just how you did the problem. So, you know, I guess if you're checking your answers in the back of the book there, and you know, it's not necessarily that you might not have a wrong answer there. Just be aware of that. Okay. And for other cases, in the last summary, the guidelines are not as clear cut. Okay. Like here's guidelines that we can use, but you know, it depends on other cases though too. Like sometimes you need to use identities. That's what we are using right here. Sometimes it's going to involve integration by parts, or you might need to be a little creative. We'll see that coming up here. And now to integrate only tangent x, you're going to do the following. Okay, tangent x, that's same as sine x over cosine x. And if I let u be cosine of x, du is negative sine x dx. Okay, so which I got in the numerator, sine x dx. I'll have a negative coming outside the new integral there. And the antiderivative of 1 over u is the ln of the absolute value of u. Don't forget the absolute value bars. That's critical here. We got a negative in front, plus a constant. Okay. U is cosine of x. So negative the ln of the absolute value of cosine of x plus a constant. That would be an answer that I would accept this if you were to circle this answer right here. Okay. Now, what your book is going to do is they're going to take it a bit further, and they're going to use properties of logarithms for some of this stuff. Okay, so the negative that I've got in front of the ln function can come up as a power, of the inner term there. So I'd have the ln of cosine of x to the -1 power. Well, that's the same as the ln of the absolute value of 1 over cosine of x. 1 over cosine of x, that's by definition how we would define secant x, right? So I could give this as an answer also, which I got circled. So the ln of the absolute value of secant x plus a constant, okay? I'll show you one more tangent integral here. By the way, if I were to integrate just tangent x, or excuse me, just tangent squared x, because I got tangent cubed x, just tangent squared x, that would be a really, really easy problem, okay? Tangent squared x, that's the same as secant squared x minus 1. And I know the antiderivative of secant squared x, it's tangent x. And I know the antiderivative of 1 is x. Right? So that'd be just to go right to the answer and you're done. Okay? Now, in this next example, what if we integrate tangent cubed x? Okay? Well, I broke away a tangent x term, and then this tangent squared x term, I'm using the Pythagorean identity. So tangent squared x, that's the same as secant squared x minus 1. I got that replaced there. And then the next thing I do is distribute the tangent x into these two terms. And I also split up the integral into two different integrals here. So the first integral would just involve a u substitution. If u is tangent x, du is secant squared x dx, right? And so I'd be integrating u du. And then this other integral is that's minus tangent, the integral for tangent x dx. Well, we've already done that, right? So that was this guy right here. The integral for tangent x dx is the ln of the absolute value of secant x plus a constant. So my answer will be 1/2 u squared. U is tangent x, so it'll be 1/2 tangent squared x minus the antiderivative of tangent x is ln of absolute value of secant x. Okay, and then plus a constant. So that'd be the answer that we got there. Okay, I'll do the last couple of problems here in this this next video.